Alright, so this is our next notes on similar triangles or similar polygons. Here we're going to look at triangles. And in this lesson we're going to look at something called angle-angle similarity. It's kind of a theorem that we look at, and if we know these two things are true, this AA or angle-angle similarity is true, it can help us figure out things we don't know. Okay, so what this angle-angle similarity says, it says if two angles of one triangle are congruent to two angles of another triangle, those triangles are similar. Doesn't mean they're congruent, it means they're similar. So here's an example how we can use this. So we have these two triangles. We have one triangle ABC that has an angle 48 and 57, and the other one, XYZ, has an angle of, don't know, has an angle of 57 and 75. Now we have two that we know that are similar, these two. So we have one angle, we just need one more. But here we have difference, 48 and 75. Perhaps this is 75 and this is 48. We just have to figure that out. We can do that by realizing that a triangle, the three angles are equal to 180 degrees. So then what we'll do is we'll solve for one of these. We'll add these two up, minus it for 180, and see if it equals to the other degree. So let's do that really quick. We got 57 plus 48. That's going to give us 15, 105. And 180 minus 105 is going to be 75 degrees, and look, there it is. So these are similar triangles based on the fact that they have three angles that are the same. Now here we figured that out, but if you just knew two, that'd be fine too. There's another example. So here we have these parallel lines and intersecting lines and all these kind of things, and well, we can see we have two triangles. Okay, and don't worry about these yet, I kind of have them in there, but I'll explain why they're true. So if we were looking at these two triangles and we knew that these angles were the same and these angles were the same, we'd have two angles and we know that these would be similar triangles. Well, they are. And we just use a couple things we know about intersecting lines. One of them is when we have these kind of lines intersecting like that, and we have these vertical angles. So we know that angles on both sides of this are the same. So we know we have this congruent triangle, but also are congruent angles. But we also know that if these are parallel, these two lines are parallel, that these alternate interior angles are also congruent. So then we know R and W are congruent. And then we could say, because we have two angles here and two angles here, they're the same, that these two triangles are similar. And we could even just go 1, 2, 3, 1, 2, 3. They must be the same. Okay. That's a simple way to look at this. There is a more complex way. Let me grab my paper. So here we have a situation that's a little bit more complicated. It's not just two separate triangles separated from each other, but here we have like triangles that are almost overlapping. And you probably see them. We have triangle BED, and then we have triangle DAC. And in this, it wants us to figure out what is x equal to and what is a y equal to. Well, we can use similar triangles to help us figure out what this x and y is equal to. And in your problems, you're going to say, well, if this is a similar triangle, and you can also kind of prove that they are as well. Like, for instance, so if this triangle, the smaller one, this angle right here, D, and the other triangle has the same angle, so we know that angle D for one triangle is congruent to angle D of the other. That's just your reflexive idea. And then also, if these are parallel, right, we also know that this angle and this angle are congruent. So we know angle B is congruent with angle A. And then if these two angles, this one and this one, we know that these are the same as well. Okay, so this is a similar triangle. Different size, it's not exactly congruent, but the angles are. Okay, but there's going to be a ratio that these share, and we can use that idea to help us figure out what we don't know, which is x and y. So if we look at this triangle, let's go start with x. We want to figure out this side. Okay, and we can use these ratios and comparisons. The one thing we do know about the small triangle, we know that BD is equal to 3. Then if we compare it to the same side of the other triangle, which is AD, and that's, we'll put that in, we know that's 5. So those are two things we know. Then we want to figure out what BE is, which is x, and then we just compare it to the same side, AC. We then plug in those numbers. So BD is 3, and AD is 5, and then that's equal to BE, which is x, and then AC, which is 3.5. I'm going to move it over here, and we're going to do cross multiplication. So 3 times 3.5 is going to give us 10.5. And then 5 times x is going to give us 5x. We're then going to divide by 5, and we're going to get x equals 2.1. We got x now. So we know this is 2.1. And then we then just need to figure out y. We're going to use the same kind of principle. And same thing. Let's go over here now. So now y, we want to do this side of the triangle, so we'll just go DE. We're going to relate it, the ratio from DE to DC. And then we're going to go to the other one we know. So we know these same triangles. We got BD. And then we got AD. Plug in our numbers. So DE is y. DC is y plus 3. Don't let that scare you. It's not going to misship too bad. And then BD is 3, and AD is 5. So then we do our stuff. 5 times y is 5y. This is going to be 3y plus 9. Okay, and then we just do our collecting like terms. We're going to minus 3y from both sides. That's going to give us 2y equals 9, and y equals 4.5. So then we know what these are. Then we could plug these in and see if they have the ratio. And if you did, and if you had your calculator really quick, you could check and compare 4.5 to 7.5, and you'd see it's like 1.66 repeating. And if we did 5 divided by 3, we would see it's 1.66 repeating. So that's another example. I just want to show you one more, and then we'll be ready to stop the notes. So here's another example. So we have these two triangles. We have to say, well, are they similar? So if we determine they're similar, we can then compare the sides and ratios and figure out what we don't know. Because we can see here we got this one has an x plus 6, this one has a 2x plus 6, and we could solve for x. So here it wants to be x equals what? Okay. And then we have to be sure that our triangles are similar. Because we have a triangle here, we have a triangle here. So the one thing we do know is we have this vertical angle, so we know that this angle and this angle are the same. We already have this angle, and this angle are the same. So then we have two angles, and we don't know what this one is, but we know that it's the same too. That's the other one on the other side that we don't know. Has to be. Okay. So then we can solve for x using these ratios that we know. Okay. So we can do WR, right? And we can compare that. This is really, it has the 1 and the 2, right? 1 and 2. We can compare that to TR. Okay. And then we can do, we know SW or WS, and we know the same angle, TV. We can plug them in. So we plug in WR is x plus 6. That's going to be over TR, 2x plus 6. That's going to be equal to WS, which is 8. And that's going to be, the other one, TV or VT, is going to be 10. Then we're just going to run this through. And we have to make sure, though, when we're doing this, so WR and WS, we don't want to like mix up and get TV in here because it'll mess up your calculations. So you always want to be comparing. So if you have this triangle side on the top, it has to be, the second one has to also be that triangle as well. So let's just run these through. So 10x plus 60 equals 16x plus 48. Then we collect our like terms. We'll minus 10. We'll get 6x. We'll minus 48. We'll get 12. And we get 2. This is y actually, right? No, it's x. So x equals 2. Okay, and there's our answer. That's kind of how you do these. And then we can plug it in and see as well, check the ratio. Because we did 8 into 10, that would be 4/5. If we then plug this one in, we should see it should be 4/5 as well. So that's our notes. Make sure you add them to your notebook, and we'll do some more stuff, more things with this in class. See you in class tomorrow.